you'll need a battery in the middle. That's why the peak shaving. The battery is designed for peak shaving functionality, and this is what our system can do. The second part is I'll combine the off-grid and diesel replacements together, because whenever there's a site and there's no electricity, they should have some power generating machine, which is normally the diesel generator. And now we have solar plus the battery to supply electricity 24/7 without any hesitation. The fourth one is the maximum self-consumption. This running logics comes with our residential collection, which is what all the battery manufacturers basic logics. Maximum self-consumption is simply just put solar as the priority, secondly the battery, and you always have the grid as a last reserve. The fifth point is the microgrid. Microgrid is a new technology or a new form of electricity distribution. Microgrid, when I talk about microgrid, I'm talking about behind the meter and in the small community. Let's say if you have 36 houses or 60 houses in a neighborhood, and then these individual houses will need to connect to the grid individually. But instead of doing that, when you develop the whole neighborhood, you put a centralized battery in the middle, and people around in that area will be able to trade or obtain electricity from the centralized battery, and that centralized battery will be a free market for this whole neighborhood. And this is what our commercial batteries can do. The last and foremost point will be the arbitrage between retail pricing. Arbitrage between retail pricing is simply what Jeff just mentioned, charging at lower rates, discharging at higher rates. It's a very simple logic for commercial battery, and it's a very important add-on feature for those commercial batteries. So when you calculate the ROI, definitely include that into the factor too. So now I'm going to run through some case studies that we have done here in Australia with all those 6 applications I just talked about. First one is the peak shaving application, the one that we have done in Wolli Council over here in New South Wales. You know those PV panels on top of the Westfield in Chatswood? Yeah. That system is now connected to this battery system. It's a 30 kilowatt charger, which is not big, and you have a 60 kilowatt hours of battery. What that does is, during a certain period of time throughout the day, whenever the power rating exceeds a certain amount, it will drag down with the battery discharging. Second is the off-grid application. This project I've been there myself. So it's in the middle of the desert. There's a local airport, Moomba Airport, and when you get off the airport, you need to drive 4 hours to get to the site, and there's nothing but a camel. I accidentally ate the fly on the way there. So yeah. So that system over there, you have a 100 kilowatt worth of PV, freestanding on the desert, and then we'll have a 100 kilowatt inverter packed into a 20-foot container with in total 400 kilowatt hours of battery. And the ironic part is this whole system is powering up a oil beam pump that's sucking oil from the ground. So they're trying to make as renewable as possible for the process, but end up having dirty oil. So with that system, we have 250 kilowatts Gfinity inverter in place and doing AC coupling. The whole system is completely off-grid. So if you check on the diagram, which I'm going to show now, when the battery is fully charged at around 12 o'clock noon time, this whole battery storage system will tell the Gfinity inverter to tune itself down by talking to the VBTS. So normally during an off-grid situation, when a battery is fully charged and your load doesn't need any more electricity, the electricity has to go somewhere. So the technology that we adopt can talk to the Gfinity inverter and ask them to tune itself up and down according to the load. And during that dark browny, yellowy kind of color, in between 5 o'clock to 8 o'clock, that's the diesel generator kicks in. So when the battery reaches, let's say 23%, which is settable, the system will talk to the generator and ask them to start working, charging the battery at the same time feed the load. And the battery, when the battery reaches a certain amount of SLC, they'll tell the diesel generator to cut itself down and start the solar generation. This is the diesel generator replacement application. This is an ongoing project. I don't have a lot of photos for that. It's also in WA. It's actually for a holiday home. They have 19 different houses that's inbuilt, and what they need is a 250 kilowatt inverter in place, together with 600 kilowatt hours to supply all those 19 holiday homes. Currently, they're running on diesel generator, and they're still gonna be using it for about half a year until the end of the year, and after that, they're gonna completely get rid of it. Maximum self-consumption application. This is a dairy farm project that we have done in Victoria. If you check out the casing, comparing to the first case study they have done, that I have spoke about, this is a bit different. It's also a 30 kilowatt charger with 50 kilowatt hours of battery, but this is an IP65 rating outdoor cabinet with air conditioners built inside. And it's freestanding too. You don't have to mount it to anything. If you open the front door, all the batteries are slot in like a rack mount thing. And EMS will be able to control the air conditioner to turn it on or off whenever you need it. Some running data for the dairy farm project. And this is the microgrid application for East Village project. BT Energy is our EPC company. They asked us to put their names up there. So, yeah, I love their owner, so that's why we put it up there. And this is one of the first commercial projects that we have done in Australia. This is a centralized commercial battery, and they have 36 different homes in the neighborhood. And on each individual of their homes, they're going to have Alpha residential Smart 5 battery. And as a centralized battery, as I mentioned just earlier, this will be working as a free market in the middle, so that, hang on a second. So house owners will be able to trade electricity in between one to another throughout that big battery. Yep.
Can you give us a ballpark price for that one?
Pricing, I'll get back to you later. This is a 20 feet container. Air conditioners and air ventilation is already built inside. And that big box is that main switchboard.
How big is the PV?
So there is no PV connected directly onto the container. All the PVs are spread out onto 36 different houses, and they have their own residential batteries in place, and they can, in theory, you don't really need the commercial battery, because each individual houses can be self-independent. But whenever they're not home, let's say they go to Europe for like a month or two, right, not using it, they can, whenever the battery is fully charged, they can pump the actual electricity into the central market, and let's say house feed is the need, then they can draw it from there.
So they get 8 days for
Yeah. Yeah, so they get paid and for the export, not only to the grid, but also to the centralized battery. And that price is settled by the neighborhood. It's a standardized 6 kilowatts plus a 5 kilowatt inverter with 11 kilowatt hours battery. That's when they build the house, that's how they build it. Yeah. No. 6 kilowatt PV, 5 kilowatt inverter, 11 kilowatt hours battery. And here's some global case studies that we have done elsewhere in the world. Just recently, I think it's Monday, I read a post of my colleague back in the headquarters. They have just did a 2 megawatt hours battery in Africa. So it's not on there, but we have plenty of these case studies around the world. In Africa, Europe, Southeast Asia, South America as well, South America, not in North America. And this is the system that we adopt over here in Australia, T50 and T100. We also have bigger ones, which is now under the qualification process for the CC listing. T50 and T100. This is a hybrid inverter system. And you can put them on-grid, off-grid, with a diesel generator. Basically fulfills potentially all the functionalities that you're after. The only down part that I don't like about this product is they only have one VBT. They can only get one terminal into the system. But other than that, the system is flawless. So for the T50, T100, you have the hybrid system. This is normally how you connect the hybrid system. You have PV connected directly into the system with one MPPT. And then you have another PV system, AC coupled into the system as well. And then you have grid, generator, and load on the AC side. This can also be the backup. So in the off-grid application, they can also put out 100 kilowatts on 3 phases. So 33.33 kilowatts per phase. And this is some coupling methods, which is similar to our residential applications. DC solution, DC coupling is simply just the PV connected directly to the system with a battery. Grid tie AC solution. You have a PV plus a string inverter, let's say a Gfinity inverter or an M-phase inverter. And that can be AC coupled into the T50, T100, and then charge it up from there. And this is for the off-grid solution. Off-grid solution, you can put PV directly onto the T50, T100, of course, and also you can do AC coupling as well. EMS is the whole brain behind the whole system that will control all components in the whole product, and they will be synchronized onto our Alpha Cloud. All the calculations are done over there, and if you do need to abstract data or do some API management or calculations, we can also open that source for you. Industrial applications, so anything bigger than commercial, we qualify them as industrial. So anything bigger than 500 kilowatts, we qualify them as an industrial application. We'll customize that and also the commercial systems as well. So if you do have a commercial quote that you're not sure about, just talk to me. Residential collection, we have done this for about 4 years now here in Australia. We've done a good job, this is a system that we sell. We have sold almost, I think, 4,000 of these in Australia, and this system is our new 10 kilowatt 3-phase system with scalable batteries as usual. All Alpha systems are scalable like a Lego toy. That's the whole point of design we have in the background. Some residential case studies. On the first one, that is the first Smart 5 system that we have installed in Australia. The middle one is the one that I went to. Is in South Australia. Is a lovely couple that wants electricity to power up their pumping system for their lavender garden, and that's pretty much all they do. All the solar panels and batteries goes. And this system in the middle is in our South Australia assembly plant in Lonsdale. It's a 10 kilowatt 3-phase system. We have installed another 5 kilowatt single-phase system to that, just for the showcase, and also it'll power up our assembly appliances as well as our offices. Alpha Cloud. Alpha Cloud is a website We have all the data over there for further calculation, analysis, etc. This Alpha Cloud, you can also download it from the App Store, iOS Store, Android, Google Play Store, all available over there. Think about if you're running a 1 megawatt power station, you can get access to it with a phone and see what's going on over there. How cool is that, right? So this is what you're going to see on the tablet or the PC. So you will see a live data of what's going on right now inside the system. That's how much PV is generating, that's how much is feeding back to the grid, that's how much powering up the battery, and that's how much you consuming the load. In the top corner, you also have today's generation, total generation, and also if you set up the currency and the right electricity tariff, it'll tell you how much profit you made today. System monitoring. This page will give you the live data. As you can see, I made up the PPT on the 24th of February, at around 1 o'clock in the afternoon. So that's the real live screenshot of what's happening in your system. And if you click on the top, there's a statistical diagram there too, so you can see the historical data. And if something goes wrong, our technicians will be able to log into the system with your permission and help you identify what's the problem really is. All right, that's it. Thank you very much for listening.